So I'm going to talk about Granite consensus, which is the work we are doing in the consensus lab. So it's about bringing fast finality to Filecoin. So basically, one of the main pain points of Filecoin consensus is its finality. So expected consensus works such that on expectation 5 storage providers from the Filecoin storage power table are selected from the DRAM input in every epoch. And they basically propose blocks. But there is no, this is basically the longest chain style protocol, which favors availability over consistency. And then you don't have practically guarantees of consistency in the protocol. So basically, there is a line in the code of Filecoin consensus that basically says, look back 900 epochs in the past, and consider that block which you see in your local data structure without actually talking to any other node in the network. Consider that final. And in principle, this is very conservative, right? So why this is done is because of this like high availability, low consistency protocol that we have, which is expected consensus. And essentially, this works under strong synchrony assumptions. So strong synchrony means that the messages are delivered on the network within a bounded time. And since you cannot say on the internet with like precision what is this bounded time, then we take very conservative time, which is 900 epochs, and it's like 7.5 hours, and then like we have like practically longer finality than Bitcoin and so on. So this is a huge pain point. And interestingly, the protocol doesn't use, so there is a power table, right? And there is an assumption on the correctness of a certain part of the power table. So in principle, we analyze the expected consensus. We show that essentially tolerates like roughly 20% adversary. Then we propose the FIP to boost this up. But there is an assumption on the number of nodes that can deviate. And the protocol doesn't use this information to finalize at all. So these are observations that we had. And essentially, the impact on product and business is terrible, right? So if you just use the exchanges, you know that maybe you don't wait 7.5 hours, but exchanges would like shrink this down to 200 epochs or so, 200 confirmations, like at least those that I used. And this is a pain point for bridges as well, like for existing applications and products, but also for coming ones. Especially for us in IPC, we use this hierarchy that Juan introduced. So basically, as you propagate stuff up the hierarchy, you're going to reach L1 at some point, and then you basically are going to use this information to go down. So when this happens is actually when you consider the information on L1 final. So when is this? Well, this kicks in again. So for nice experience of IPC, we are going to have to solve this problem. It limits FVN applications and so on. So I guess this is one of the main problems that we have in the Filecoin network today. So if you want to solve this problem, so once we start solving this problem in Consensus Lab, like we wanted to see what are our options, right? And we roughly separated these 4 options. So basically to replace expected consensus by another longest chain protocol, to replace it with a BFT protocol, where BFT stands for strong consistency, so a protocol that favors consistency over availability in some cases. So when it needs to basically stop during adversarial attack, it would stop being, like, it would stop progressing as opposed to, but it would always be consistent. Then basically there is a line of work, which is very popular these days, where you combine a longest chain protocol with a BFT protocol. And then a final option is a variant of these, where we actually have a new longest chain protocol combined with a BFT. So in principle, we quickly eliminated the first one because it's like you would see these problems again, right? As you know, in any longest chain protocols, like maybe we will be able to come up with a longest chain protocol that we could have faster finality than 900 epochs as it currently stands, but it wouldn't dramatically improve things. And for the similar reasons, we eliminated the last option as well, which leaves these 2 options on the table. And basically, if you just, so there is a separate discussion of how easy it is to replace, for example, in Lotus, consensus. And I can leave to my team members from Consensus Lab to debate on that, because this is what we are wrestling with IPC. But like, so there are software development challenges. But the even fundamental challenges is like if you have a BFT protocol, then you have this like consistent growth of a chain. But then if something goes wrong, if you have a partition in the network, then the network will stop producing blocks. And this is what you see in protocols like Solana and like these are the family of blockchains that actually favor this, right? So it comes with bad publicity and whatnot, right? So, but the bigger reason is because we need to implement this BFT protocol in any case. The biggest one of the bigger reasons, at least for me, was that like taking EC out and putting a BFT protocol in is a challenge to do in Lotus, right? So this is why we actually lean to option number 3. I mean, this is still under, as you will see, this is a FIP that is under discussion, so everything is open, but this is why we are favoring this option, at least. Yeah, and recently there was a lot of work, especially from the group of Stanford, from David Se, which basically looked at this availability consistency dilemma that recommends, but basically that we combine a longest chain protocol with a finalization module based on a BFT protocol. So these works, if you just go to these papers, they don't recommend which protocol to use as a BFT finalization module. And then we, in the consensus lab, we basically try to come up with a protocol that would be simple to implement yet efficient, and this is how we came up with Granite. So Granite, as the name, was chosen because it like demonstrates quality of something that doesn't change in time, right? So this is why we chose it. I hope you like it. And this is the summary of its characteristic, right? So it's a variant of a classical Braha's Byzantine binary consensus, where you do consensus on like input which is 0 or 1, and then we generalized it to multi-valued consensus. It's a fairly simple protocol that you will see. I mean, I won't go into explaining protocol, but the high-level logic fits in one slide. So this is the whole high-level logic of the protocol. It tolerates 33% adversary. It doesn't make assumptions on the network synchrony. We have different variants of the protocol, some that make assumptions on the like eventual synchrony of the network, but we are going to favor basically a version that doesn't make assumptions on the synchrony on the network and circumvents FLP impossibility result for those of you who know what this is, using randomization. It's leaderless, which makes it nice for addressing the distributed denial of service attacks. And it's fast. So most of the time, like its expected latency is like 3 message delays over the network, which means that we are going to be able to finalize blocks in the same epoch. Like if the epoch, let's assume we keep the block time, that's a separate discussion, but let's assume we keep block time at 30 seconds for the moment. We would be able most of the time to finalize the block at the same epoch where this is proposed. So how we are going to do this is basically this will be the architecture. So if the current expected consensus builds the chain, so here we are abstract tip sets as blocks, right? Builds the chain, then we would have a finalizer module that reads the head of the chain locally from the expected consensus. So that part is unchanged and uses this as an input to Granite. So this has several advantages. So first of all, we reuse a lot of code, but then we don't disseminate messages again. So basically, you can do agreements just on the hash, on the CID of the block, without actually disseminating. Like, we don't need to care about that, right? So we are feeding this as a proposal to Granite consensus, which goes again to the network to communicate among nodes. So who are the members? The members are the basically storage providers in the power table. So we are doing an agreement among them. And we are using Granite consensus protocol. We are weighing, so each vote has the weight depending on the weight of the miner in the power table. And we are doing this agreement. If we need to inform full nodes of the decision, we can have a separate gossip subchannel in which the storage providers actually publicize the decisions and then inform full nodes of this decision. And basically, we output some block as final, depending on the Granite consensus output, and basically this determines the finalized chain. So there are a few open design questions. Whether we are going to use Algorand style, like not Algorand, but also Filecoin style committees, not necessarily of size of 5, but larger? Or are we going to do Granite on the whole population of roughly 3,500 miners? We're still evaluating this. We would keep DRAND as the source of randomness for the moment, although we could use others, but also not to introduce too many changes. This is our current proposal. There was a lot of discussions whether we should keep tip sets or blocks. This decision is not only, like for this architecture, this is a minor question, like we could apply to both, but the difference, like if you move now to blocks, it might have impact on crypto economic like implications, like you don't have five miners or expectation that get rewards by one. So we would leave community to decide this, but like maybe at the moment we are just gonna leave tip sets and then basically finalize tip sets instead of single blocks. And block time, initially we also looked at maybe we should look at reducing the block time from 30 seconds. I'm talking about the single epoch time to lower. But arguably, this is an orthogonal problem. So for this moment, like we are leaving the block time at 30 seconds. The epoch stays the same, and this can be subject to another FIP. So basically, this is some background work that we did. We have a like simulator in which we evaluated different protocols before we came up with Granite. And there is a TLA plus specification of Granite that gives us more conviction that this is basically correct protocol. So what's going on now is there is a FIP discussion as we speak, and the goal is to write a FIP, let's say by the end of September, so in the next 2-3 weeks. So please join the discussion. I summarized quickly basically what's there, but if you have inputs, please of course speak now, or if you want to do it asynchronously, join the FIP discussion.